Hi, welcome back to the breadboard. A few weeks ago I had a surprise package arrive at my door and I wasn't expecting it, hence the surprise. When I opened it up and discovered what it was, it quite intrigued me, and so I spent the last couple of weeks or more getting to know this product and putting together a little demo for it. So what is this product? Well, let's go have a look. This is what it looks like. It's a fairly innocuous looking brick, basically. It is from a company called Harting that is based in Germany, but that has offices all over the world. It's called a Harting MICA, M-I-C-A, and what it is an IP67 rated certified automotive and rail use microcontroller industrial interface. Its purpose is to primarily take legacy components of a system and allow you to integrate them to the Internet of Things and also to other parts of your control systems and monitoring systems. What's in this is a Arm Cortex processor, 1 gigahertz with a gig of RAM and 4 gigs of flash memory for putting programs in. It's running Linux, and it's running a containerized based system so that you can have up to 8 virtual applications running that cannot interfere with each other. And the primary operating system is Linux, and you can have a container in here using Debian Linux, the same as what is used currently on the Raspberry Pi. And what I have is I've set up a bunch of demos to allow me to show you what it can do. It has 2 connectors on it. That's all there is on here. You can get ones with a USB as well. Now these connectors are fully waterproof, etc., being that the whole unit is IP67 certified. There is a panel here that is not recommended to take off because it is sealed, which has an RFID, that's not NFC, but RFID components behind here so that you can read off some of the parameters of this unit without having to go to a web browser. The 2 connectors that we have here, one of them is for Ethernet connectivity and it supports power over Ethernet. The other one is to allow you to connect up to 8 I/O devices. These are up to 24 volt devices. They can be inputs or outputs, although the inputs are just either a switch closed or open. It's not for analog or anything like that. It's just digital inputs. The outputs can be up to 24 volts, but they can be less if you want to as well. And I'm going to hook up a little demo to show you how you can use this. The power over Ethernet does not power the I/O, so you still have to power that locally, but that's not necessarily an issue depending on your installation. It just allows you to have the options of how you power this thing. So as I said, there's not really much else I can show you. This is a solid metal case. You can see by the size of my hands, it's not much bigger than sort of like a Raspberry Pi in a case kind of size, but it is IP67 rated. Now you can get, I don't have it, but you can get a DIN rail mount adapter for this so that it can either mount on DIN rails or other mounting options, and or you can just sit it on a shelf or somewhere else that's convenient. There are 4 screw holes here so that you could mount it to some kind of bracket if you wanted to. Anyway, there's not really much else I can show you just looking at this, and so what I want to do is get it hooked up on the bench with some lights and switches, and also get a web browser hooked to it, because the way that you actually use this is you completely talk to it with a web browser. There is no X windows, there are no VGA, HDMI outputs or anything like that. It's purely command line with an SSHL, and the main administration interface is via a web browser where you talk to a configuration screen and administration functions, and we'll go through those in a moment as well. So a close-up of the unit, the first thing that's pretty obvious is these 2 connectors. One of them is the Ethernet with power over Ethernet capability as well. I got an adapter with the unit when it arrived, but you can pretty much use any power over Ethernet adapter that gives out up to 48 volts on the line. The other connector is an I/O connector, which has got well, we'll go into a diagram of what this actually provides, but there's basically 12 wires coming off of here. You've got power, you've got 8 I/O lines, and then you've got an additional 2 lines that help 2 of the I/O lines are uncommitted to high drive or low drive. So we'll go through a diagram on the web screen in a minute to show you how that is configurable and what it looks like. Both of these connectors are also made by Harting, and they're IP67 rated. So once you put the mating part onto it, it becomes fully waterproof. So this is the other part of the power over Ethernet connector. I don't know if I can get that to focus easily or not. There you go. So that's that connector. So we just plug this into the PoE port on here and screw it in. Now I'm not going to nip these up with a wrench or anything, although normally you would if you want to get them fully waterproof, of course. So now that's powered up because I've got the other end hooked into a PoE interface. Now just screw the other connector in, and this one's a little stiffer. I think it's because it's got more pins. Okay, all right. So the other end of the GPIO connector is this one here. So I've brought it down to a set of 0.1 inch pitch headers so that I can plug it into a breadboard. I've got 3 of the outputs connected to some little 12 volt LED strips. I've got 2 of the GPIO pins connected to this switch, so I can either close one side, neither of them, or the other side. And a last one I've hooked up to a magnetic limit switch, so we can see when we get some magnetic metal object near it, it should close and indicate to the control system that there is a close contact. Now, as I said, the idea of this is so that you can hook it up to some legacy I/O devices and monitor maybe a door that's open and closed on a train, or a thermostat that might indicate just a high temperature in an engine that's been around for a long time and maybe doesn't have an electronic control system. You could put a temperature sensor that has a contact that just simply closes or is open, depending whether it's within or without temperature. And it's limited to your imagination. You've got 8 input-output lines that you can either have a normally closed contact that would open to indicate some kind of condition, or you can have the 4 high side drivers that can drive some kind of load up to 24 volts at 100 milliamps. So that could be driving a relay that then power something else, or you could be driving some low powered lights or anything else you might care to hook up to it. There's also 2 low side drivers and 2 uncommitted drivers. So before we get into a little bit more of this, let's just have a look on the web page for the actual devices that are used for the I/O on this, and it'll help you understand a lot more what is going on. So this is a look at the website from Harting, and what we're looking at here is a little bit of the view of the inside of the mic. If I scroll down a little bit, this is the one that I have, which is the MICA Basic, which includes the Ethernet port and the GPIO. You can get customized I/O subsystems added to this if you want, and you need to talk to Harting about that if that's something that you would want. There's a little bit of the view here on their website of the administration screen, and I'll show you some close-up live images of that in a moment. Their website does have a huge amount of information on that you can look at regarding the MICA, including some demonstration containers that you can download and try for yourself, etc. We're going to look at a couple of those in a moment. What else is on here is a little bit about the IP67 rating of the MICA with 24 volt GPIO lines. This is the specifications for the processor here, so 1 gigahertz Arm CPU. Now this is a Texas Instruments Sitara processor, and the reason for that is because it is one of the few Arm Cortex processors that actually has automotive and rail certification. Now remember, this whole unit is certified IP67, but on top of that, it is certified for use in the rail industry and in the automotive industry, which takes a lot more work and reliability because of safety and various other things to get that certification. So the TI Sitara processor is one of the chips that does that. Anyway, it runs at 1 gigahertz. It's got a gig of RAM, 4 gig of eMCC, and there is a socket. It's actually about here on this middle board behind the plastic panel, where you can put a 32 gig micro SD card. It does mean you'd have to break the seal to put it in there though. So if you're going to run it in an environment where it may be damp and things like that, you would have to reseal it. Obviously industrial connectors, and that's one of the things that Harting specializes in, is making these kind of connectors. Anything between 12 and 24 volts for the PoE, the power over Ethernet. It's all based on Linux, and it's using the LXC, which is the Linux Container System. If you want to evaluate this on your own Raspberry Pi and things like that, even without having this board, you can actually download it for free for the Raspberry Pi or something. This comes with it installed as standard, and it works and seems to work very, very well from what I've tried over the last couple of weeks. Programming guide, one of the PDFs you can download is a basic programming guide. Now, this is a very, very new product, so it may be that you or this will be updated over time, and it probably will be. A little bit about the virtualization, another PDF. All of these are available, as I said, directly from their website, www.harting-mica.com, and you can just download them and look at them yourself. As I said, this uses the Linux containers LXC to do its virtual machines. So it's not really a virtual machine in that you completely reinstall Linux and everything else. It's more just the delta between the host and the application that you need to run that application that goes into the container. So it's a lot more optimal and has a much, much smaller footprint, which is why that even though this is a single core, it still performs very, very well for its size and specifications. This is an example of the home page. This is talking directly to the base LXC web interface that's been set up. Now, this has obviously been customized by Harting for their product, and you can get this customized by talking to Harting as well if you want to suit your own environment. I've downloaded a few additional containers here. One with Java, a Python one, a GPIO remote demo. This GPIO one here I'll show you in a little while. I've got an empty Jessie container, which is the Debian Linux, and I've got a one that I've been using and I've set up with Node-RED and everything else, which I will demonstrate to you. The installation button here is designed to allow you to create new containers. If I go into my Jessie container and look at the configuration, you'll see it's got a static IP address of 201 already. I've set it up to use DHCP for the moment, and I don't have a web page on it. I also have a GPIO demonstrator here, which if I start this one, all right, so if I go in here, this is a GPIO demonstrator that it's a container that's been put together, and it talks to the GPIO lines. You can decide whether they're input or outputs, and if they are outputs, you can decide whether they're on or off. If you have them selected as inputs, then they will reflect the state of the input, whether it's on or off. Now remember, I said this is not logic levels. This is, do I have a switch closed or do I have a switch open? If you set this to auto, it will expect that you have an MQTT server set up for it. And I do have a demo which I will show you shortly that actually integrates with an MQTT and then back into a Node-RED instance so that you can actually communicate and show how easily it is and how quick it is to do that. The next thing I want to show you, so that's that. The information will just give you basically what revision of software you're running. I have an application here written in Node-RED. I have two of them. One is an MQTT demo, and then this one is talking directly through a Python wrapper to the GPIO pins in the hardware. So it's because it's Python and it's interpreted and you've got to load the container every time you invoke it, it's a little slow, but it does demonstrate the point. Now, Harting has also now provided me with a C wrapper, which should be a lot quicker. And you can also generate one in Java if you want to, which will be even better for using of Node-RED. So what is the GPIO? The way that the MICA is structured from a basic building blocks perspective, you have your power over Ethernet enabled CPU core, which is running the Linux core and all of your containers. And then there is a USB device which is based on the MCP 2210, which exposes a SPI interface to your custom interfaces, or in this case the GPIO controller, and on the other end is the USB interface, which is what is exposed into the Linux operating system. So everything you do it basically using a USB protocol through to the back-end device. So if you make your own custom I/O board for the Mica, then you would just simply put a SPI device on the end of the USB interface and you can just talk to it. This USB MCP 2210 can support up to 8 separate SPI devices from a physical perspective. And you can see these are the GPIO 0, 1, 2, etc. I'm not going to go into how this MCP 2210 works. Suffice to say that it is basically a USB to SPI protocol converter, and you just set up buffers of data that you want to be transferred to the SPI device. You select which SPI device you want to talk to, you send the data, and you get responses from the SPI device. So once you've got the wrapper set up, really your programming is reduced now to effectively talking to the SPI device. You can abstract all of the USB things away from your core code if you want to. And that's what the Python and other demos have done for us. They've abstracted away some of the talking directly to the SPI device or the USB device. But the source for the Python, because of the nature of it, is going to be available to you, so you can have a look yourself at how it's done. And if you want to rewrite it in Java or something else, then you're quite welcome to do so. The other device that's at the end of the MCP 2210 for the standard Mica Basic is a device from Infineon, and it's one of their Spider range, and it is a TLE7238S device. And what this is a relay control device. It's a little bit special in the way that it works from Infineon. It's obviously certified to work in this kind of environment with automotive and rail devices, but this is the basic block diagram that's relevant, that will explain how the device works and why, when you look at the configuration that's on the Mica website for how you set up the ports on the GPIO lines and things, it explains exactly why they are the way they are. So you have 4 lines which are high side drivers, and you can see here's all your control circuitry on the left hand side, and they ultimately end up talking to some MOSFETs. Your plus rail, which can be anywhere between sort of 12 and 24 volts, goes through to 4 of the MOSFETs, and then they're driven what you would call high side. So they push out 24 volts up to about 100 milliamps or so per line. And then next to that, you've got 2 uncommitted automatically configuring MOSFETs, where you can either take S4 and S5 and ground them, and then have a supply feeding through your load and then into D4 and D5, or you could connect D4 and D5 to, say, your plus rail and have S4 and S5 driving high side out to your load. And the last 2 outputs, output 6 and 7, there, as you can see, clearly syncing MOSFET outputs, where you would have a supply going to your load, and then you would come into the MOSFETs, and then it would go down to ground. And obviously the high side is based on whatever voltage you supply to VBB, and the low side is whatever voltage you supply to your load, which doesn't have to be the same as VBB. It could be, say, 5 volt loads here and 24 volt loads up here. The same for these 2 middle ones. You could have, say, 7 volt high side and 3 volts on the low side for some reason, and some load in between if you want to do, and it would still work just fine. I will provide a link to the data sheet for this so that you can find out more for yourself. This is just the summary that I'm looking at right here. When you look at the specifications, it actually says that these are only outputs, but one of the features of this is that there are some short circuit detection and open load detection built in, and if you turn that on, if your output is not turned on as an output, the diagnostics currents that are passed through these output stages will know whether you have a load connected, or if and what that means is that if there's a load there, i.e. this pin, say, out 0, is connected through a load to ground, it will be able to detect this voltage on this pin, because if the MOSFETs are turned off, then it's going to be sitting at maybe either 0 volts or close to it, and the threshold for these is sort of about 4 or 5 volts, I believe, according to the specification. So if you put a switch here to ground, if the switch is open, it will show up as an open load, which means that you'll be able to detect that. And if the switch is closed, it will assume that there is some kind of load connected to that input, or a logical 0. So it is very easy to hook this up and use it as an input or as an output. And if you're worrying about the fact that if you put a switch here and you have it connected to ground and you've got 24 volts up here and you turn this MOSFET on and you're going to blow up the device, that's not going to happen, because you also have overcurrent protection and temperature protection built into this chip, which will inhibit it from doing any damage to itself in those kind of circumstances. So you're more than well protected. Okay, so I mentioned at the beginning of the video that this also has RFID, electronic identification, and this is a view through that plastic panel that's on the back of the mica to show you the edge of the PCB that actually contains the RFID circuitry. This is also showing you where the micro SD slot is in the back panel as well. If you wanted to put up to a 32 gigabyte micro SD in there, you could. So to just close off the overview of the Harting MICA device, I'm going to go into the second video with actual practical demonstrations of it. This is the hardware development guide PDF, and what you've got in here is a little bit more about the physical hardware of the device, showing you which connectors are what. So you've got connector A and B, so you've got the B being the power over Ethernet, and A being the GPIO. A little bit about the power supply that you can use with it. This is the GPIO connector. Continuing down on the guide, here's what I was explaining to you about the inputs and outputs. So if you're using it as an input, you have your 24 volts coming in this case, and then pretty much any of the output pins, 0 all the way through to the 7, you can have a switch connected to it. In this case, when the switch is connected, it's going to show you when you talk to the GPIO pins that there is a load connected. So when the switch is closed, it's not a logic 0 that you're going to see. You're actually going to see a 1 or a high coming out effectively from the call to say what is the state of the pin. But that just means that it's telling you that the switch is closed, not that the input is high or low. Because when you do the low side switches here, we're using output 6 or 7, the same condition. So this state where the switch is closed on input 0, it's going to say, yep, I've got, you're going to get a 1, and you're going to interpret that as being active or closed. In this side, when it's closed, you're going to get a 1 as well, saying it's active or closed. It's not saying it's high and low. So you need to remember that when you're coding and when you're explaining this to your developers, or who is wiring up and running, setting up some of the higher level code for you. This is using it as an output. In this case, they're showing you indicators, like they could be LEDs, they could be incandescent bulbs, or whatever it may be, being driven. So you got 24 volts coming in this case, and your output is going out to a load, which, as I said, you could be a small relay here, which then, or a solid state relay, that then could be driving some mains power devices, or this could be a low voltage enabled contactor or something to start a motor, whatever you want. This is the high side equivalent, where it's using the low side FET, so your power goes into your load first, and then finally it's showing the uncommitted switches using the high side connected load, and low side of the switch is being connected to ground to complete it. Another look at the connector. In this case, it's actually showing you the color of the wires that come as the accessory for the GPIO connection. And finally, a little bit of a discussion about the fact that you can get a customizable circuit board for the mica, where you've got your data bus lines coming in, and then you can put your own GPIO type of device, ADC, DACs, whatever you like, onto the customizable circuit board. I haven't opened up my mica yet to see the mica basic to see if one of those is in there. And of course, if you do customize it, you would have to make sure that you put an appropriate connector on the front panel. Otherwise, you're never going to get the you're never going to maintain the certification for the IP67 rating. And of course, if you want to maintain automotive and rail certifications, then you have to take those factors into consideration as well as far as what you hook up to the device. Harting, so far, with all the work that I've done with them, have proved to be very, very good at providing support to me to get this up and running, as well as explaining how parts of the operation work and providing some wrappers. Like they provided me a Python wrapper that I then extended a little bit to allow Node-RED to talk to it so that I can actually control the hardware from Node-RED. And I've put together a couple of demos, which are now going to be in the next video, to show you exactly how you do that. For this, though, I just wanted to say that yes, this is a really nice little device. It can pretty much go anywhere because of its certifications, both the IP67 as well as the automotive and rail certifications. And you know, you can't have too many high expectations for it. Don't think that it's the power of a Raspberry Pi with all the GPIO of a Raspberry Pi. It's not. It's a hardened industrial interface device that will allow you to attach legacy devices as well as new ones. It doesn't have to be legacy. And bring that information into the Internet of Things. Because you've got an Ethernet connection on here, you can then bring it out to the cloud if you want to big data storage or whatever you like, or you could keep it private and send it to a higher level control system. You can very easily have it send data out to an MQTT server that is then interrogated by other control systems and high level applications to analyze the data and things like that, and to maybe have some trend analysis and things. And once you've got it there, of course, you know, the floodgates are open as far as what you do with that data. And it can very, very easily read from MQTT and control its outputs or do other things with that data that it can read from there, or anything else. I mean, it doesn't have to be MQTT, and I will show you that. You know, I've actually got Node-RED up and running inside of this in a container quite happily. So what you do with it is completely up to you. Now, the fact that it can run 8 containers all isolated from each other at the same time is a really nice feature. I'm not 100% sure how useful it would be, because if you're not actually monitoring the actual I/O on each of those containers, then you know, you have to go via the network or something to communicate between the containers. And if you're doing that, you might as well go to a higher level application that's maybe in a more friendly environment or with a more powerful computer, and reserve the processing power in here for doing some local control with the GPIO and things like that. But that doesn't mean to say that you can't do some computational processing in here if you wanted to. It's perfectly viable, given the fact that you've got a full Linux environment here, and you can run either Java, Python, C++, C, you know, pretty much anything within reason that you can put into a Linux container, and away you go. So, you know, while its primary purpose is to interface the GPIO and get that data over a network to some higher level control system, you can do a lot of different things with it. And from what I've seen so far, it has been very, very reliable. When I go through the programming and demos, I will point out a few little things to be careful of when you're using this. And these are just because it's a very new device, and Harting is still working on improving some of the functionality and things like that of the administration. This is not to say it's not robust. It is. I haven't had one instance where I've had it hiccup on me or anything in the last 3 weeks, and I've just left it powered up the entire time. But me personally, I've made a couple of mistakes, which I will talk about when I go through the other videos, but they're due to my not reading everything carefully and understanding fully what I was doing before I went and clicked on a button and things like that. Anyway, that's it. So this is a really, really nice product. I don't know how much it's going to be selling for, but because of the certifications that it carries with it, I don't expect it to be
the price of a Raspberry Pi or even close to that. It's going to be on the higher end of the price range. But if you need a device like this that is certified for these environments and you know, then you're not going to be questioning too much the price. You want to be able to get the product, hook it in, and know that it's going to work reliably, and that you don't have the headaches of getting it something certified yourself. This will just go in there, and as I say, it's a very small footprint, so it's not going to take up much space and be a problem in pretty much any environment. Even a small car or something, if you put it in there for some monitoring, it's not going to be much of an issue.